Bayes theorem, another problematic topic within probability and stats. This is a concept that bothers a lot of students. And in the program, what I have done is I have actually derived the entire Bayes theorem in the on-demand course. How many of you have gone through that derivation? So I've used law of probability number 2 and law of probability number 3, joint probability. And based on that, I went through a stepwise derivation and also used the Venn diagram. So feel free to skip it, okay? Because I don't know like how they can test you on a derivation. But my strong recommendation, if you really want to learn it properly, is to actually bite your teeth into it, okay? So this problem, this question, and remember in the program, in the on-demand, we discussed a very systematic mechanical approach. Once we get the theory down, right, I gave you guys a very systematic approach for dealing with Bayes theorem. It was a 4-step process. I'm going to review that over here. So let's look at the question that the student is asking and then read through the actual question, utilize the stepwise process, and see if the stepwise process fails us. And if not, then what is the confusion that the student is running into? So the student is going through additional practice problem lectures, specifically problem number 3. In such problem, the direction suggests that given that it rains, the forecast is correct 90% of the time. And given that it does not rain, the forecast is incorrect. So capital R is incorrect. So we probably need to focus on incorrect over here 10% of the time. If this is the case, shouldn't we use the counterpart of this probability, that is 90% of the time is correct given it will rain? If we solve this problem as you did using 10%, we would get probability of FR complement and R complement, which I believe is incorrect. Okay, so just we got a sort of a decent idea, high level, rough idea of what the student is asking for. Now let's look at the problem statement. You are planning an outdoor barbecue tomorrow. It typically rains only 5 days each year in your town. Which state has this kind of lucky weather? Well, I know for Florida for sure, I think it is sunny, at least partially for a time of day, 360 days out of 365. But I mean, it rains more than 5 days, obviously. But that was the kind of stat I think I read about Florida, for most of Florida. Okay, so it rains only 5 days each year in your town. Probably be living in a desert, right? If 5 days each year. According to the weather predictions, you can expect rain tomorrow. Now, this is the key. When it rains, okay, so it has rained, right? So when it rains, we know it's raining. There's no doubt about it. When it is raining, look at the forecast, right? For rain, it is correct 90% of the time, okay? So one of the key steps in Bayes theorem is to come up with the correct variables, translate them into the given absolute probabilities and conditional probabilities. So absolute probability of rain is 5 days out of 365 days in a year. Absolute probability of not raining is 360 days out of 365 days, correct? Are you guys fine with this conditional probability that when it rains, the forecast is correct 90% of the time? So F subscript R is the forecast that it is going to rain. Now the second piece, that's where the student is having question and concern. When it doesn't rain, so it's not raining, I know for a fact that it's not raining. It's given that it's not raining. Any issues here, guys? The station incorrectly, so he had this incorrect. Okay, let's highlight this. Incorrectly forecast rain. This is where he went wrong. So what the forecast was still that it was going to rain, right? Probability of the forecast was to rain, but it did not rain. This is equal to 10%. Do you guys see any discrepancy here? Or did the student just overthink? Okay. We need to systematically convert these into joint probability, conditional probabilities. If we don't do that, then we're going to run into these type of doubts. And that's why the 4-step process that I discussed in the program is so helpful. Now let's see what the question is asking. The final punchline is that what is the probability that it will rain tomorrow? So what is the probability that it is going to rain tomorrow? Okay. And we are already given, right, the prediction that you can expect the rain tomorrow. So what is the probability that it is going to rain given that the forecast is for rain? This is the unknown. Does it make sense, guys? So the question is probability of rain given the forecast is rain, which is not the same thing. These two guys are not the same. They're not equal. They are not equal. This is knowing that it is raining, and then we go back and we see, okay, how reliable our weather network is, and we check the forecast. 90% of the time, they're correct when it is raining. All right. Now, if we get into the mechanical mode after we've done all of this hard work, that is super easy because this formula for Bayes theorem is given to us in the reference handbook. We don't need to memorize it. It's kind of, not an easy formula to memorize. I'm not a big proponent of memorization anyways. My own memory is not that great. And I don't think that's what they're testing you on anyways, okay? So we put this formula in front of us and we're gonna go into a mechanical mode. I know that this is the unknown. That's what we are after, correct? So B subscript J corresponds to R and A corresponds to F of R. So let us convert probability of B subscript J into probability of R. So A is going to be replaced by F of R. B subscript J is going to be replaced by R. How difficult it was that? Just step by step identifying and connecting the dots, right? In step number 3, I would say, because the step number 1 was the correctly laying out the variables, and then identifying the absolute probabilities and conditional probabilities. I'm going to take this whole thing that appears in the numerator and put it in the denominator, right? And then I look at the other conditional probability that has not been taken care of. So F subscript R given R has been taken care of. The conditional probability that has not been taken care of is this. So I'm going to put this conditional probability over here, right? And then in this conditional probability, guys, what I find is that it is based on the condition R complement. I'm going to simply multiply this with probability of R complement. The first conditional probability was F subscript R given R. It was based on the absolute probability P of R, right? So that was this guy. This is based on P of R dash. Does it make sense? Now, when I look at how I set up the problem based on what was given to me and what was missing, this is a slam dunk from this point onwards, right? Okay. So thinking through the problems, very important. Overthinking a problem, creating a version 2.0, 3.0, 4.0 from the given problem is not going to help you. So read a problem once, read a problem twice, okay? And then systematically translate that into the mathematical equations that we can use, okay? But don't overdo it because then you are going to sort of tangle yourself in, in difficulty. And there's a huge difference, right? This was given to us that when it is raining, the forecast is accurate this much, right? And whereas this is that the forecast is for rain, okay? And then will it rain, okay? And we've discussed this in terms of visuals as well in the on-demand and live training. So identifying sometimes directly or just writing out the unknown conditional probability that itself can be very, very helpful. That by itself, all alone can be very helpful. Okay, stepwise process for Bayes theorem. Remember what we discussed in the course. Use easy and distinct variables to define events. And I think we did more than half a dozen practice problems. Kind of difficult, the ones in the homework assignment. And then within the lectures, progressively increasing. Then you have quiz problems and you have on-demand content, tons and tons of stuff. So easy to remember, identify, and distinct variables are very important. If your variables are kind of wishy-washy, then sometimes it can become very difficult. Identify the given probabilities as absolute or conditional. So absolute probability that it rains 5 out of 365. Conversely, it means that it doesn't rain 360 out of 365. Conditional probabilities, we translated that very carefully. Typically, the issue is in conditional probabilities. Students sometimes rush through the stuff, and conditional probabilities can be very difficult if you are just rushing through them. So be careful. Identify the unknown probability. So look at the question and clearly spell out what you are after, right? What the question is asking. Don't solve for something that they're not asking. Okay. And then once you get to this step, write out the base formula and then go into a mechanical mode. You can turn your brain off at that point in time. All you're doing is just connecting the dots. Okay. So the trace, when you're doing a portrait or whatnot, right? So the trace is already done, right? Okay. And then you're in a mechanical mode and just basically connecting the dots. This should be easy stuff. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.